Okay, let's take a very basic look at what recursive functions are. And I'll try to explain the call stack and all of that as well. Okay, so they're just basically functions that call or return themselves. So if we have something like this, let's call this function recursive count. And it will take in a number. And our recursive functions need to start with a guard clause. That's something like this. If num, let's say if num is less than 0, so we're just going to count down to or from 0. We're going to just return. So this is our exit clause or guard clause. Otherwise, what are we going to do? Well, let's just console.log num. And then here, we're going to call this same function, passing in the number -1. And then down here, I'm going to call recursive count, passing in 3, and see what we get here. Okay. Let me open up to the console. So we get 3, 2, 1. If we put the console.log num after the recursive call, what do we get? We get 0, 1, 2. Let's put it back on top. 3, 2, 1, 0. Okay, let's talk about this. When we call it with 3, this guard clause does not run because 3 is, not less than 0. The console.log runs. That's how we get 3. And then this runs. What happens here? Well, this is the function call, right? When it calls itself passing in 2, another execution context runs. That means another function runs where it pretends the number is now 2. So then this still doesn't run. This console.logs 2. That's how we see the second 2. This runs again. It calls the same function, passing in 1. Now console.logs 1. Calls itself again, passing in 0. Console.log 0. Okay. But now when it calls itself with 0 minus 1, it gets -1. Now the exit clause runs. Then the function stops. If there were no exit clause, this function would keep on going and going forever. Right? Now let's explain why if we put the console.log on the bottom, we get 0, 1, 2, 3. So now what's happening here? Well, this still doesn't run. This would then call itself with what? 2, right? So when we call it with 3, it returns a function where it calls it with 2. Then it returns a function where it calls it with 1. This should be 1. And then it returns a function that calls it with 0. Then that would just exit. Okay. So when it does it this way, the console.log statement has to wait for all of these returns to finish before it can even run. Okay. This is very similar to promises. It's like saying await all of these recursive calls before running the next line. And actually, this is exactly the same as promises, because what are promises? Promises are just callback functions. Okay? And callback functions are just functions that call other functions, including recursive functions. Recursive functions are just functions that call itself, right? So it is a callback, but not all callbacks are recursive functions. So then let's talk about how we got this console.log. Why did it console.log 0 first? Okay. So let's put this back. So this returns that, and then exits. Okay. So this is how the call stack works. They work on the principle of LIFO or LIFO, means last in will be the first ones out. Okay. So the last thing, when it exited, right, it was called with num equal to 0. Okay. So since 0 is the last thing returned, it will be the first thing that's ran on the next line, right? Or console.log. So console.log passing in 0. Okay. And then it goes backwards. It sees, oh, since 0 returns 1, going backwards in the call stack, it will console.log 1 and then 2. Unlike before, where if we put console.log up here, it did not have to wait for all of these recursives to run. So then what happened was the number was 3, so it just console logs that, right? And then the recursive calls itself with 2, passing in 2, then the console.log just grabs it directly from the argument and console.logs 2. So that's why this way we get 3, 2, 1, 0. But the other way, due to how call stacks work, right, last in, first out principle, we get 0, 1, 2, 3. Okay, let's work with another example that's a little bit more complicated. Let's create a very similar function that returns an array instead. So I can explain how things work a little better. Let's see, let's call this recursive count ARR. Again, it's going to take in a number. And let's do the guard clause. If number is less than 0, it will return an empty array. And we'll see why this is useful soon. Okay. What are we going to do in the body of this function? Well, I'm just going to do something like const ARR. Actually, let's be explicit. Let's call this final array. But its value is going to be equal to all of the returns of its own function call, passing in number -1. Then I'm going to do final array dot push, pushing in the number. Then I will return final array. Down here, I'm going to console.log and call this recursive function, passing in, let's say, 4. Let's see what we get. Oh, num is not defined. Oh, that's because I used number here. Okay, so we get 0, 1, 2, 3, 4. Good. But the thing that I want you to look at is right here. Const final array is equal to all of these return calls. How was it able to push in a number? Okay. Well, because when our number is at -1, right, less than 0, it returns an empty array. So once again, every function call creates an execution context, right, in the call stack. So then when we call this with 4, it returned to us the call with 3, with 2, then with 1, then with 0, which 0 returned an empty array. And then due to this principle, last in, first out, right, its final value will be the last thing that it returned, which is an empty array. Okay. And then it goes to line 14 and it says, okay, I'm now an empty array. Let's push in number. But right now, what is number? Well, when it was an empty array, the argument or number that called it was 0. Okay. Because when you call this function with 0, that's when this if guard clause runs. So it pushes in 0. Now it returns an array with 0 inside of it, like we saw, right? And then it tells itself, hey, when I was 0, which number called me? Well, it goes back where it's in the call stack and it sees 1. So it pushes in 1, and so on. Okay? So that's how we get 0, 1, 2, 3, 4. That's how the call stack works. So that's how recursive functions work.